So I gave you the graph paper because we're going to be doing some more. By the way, that thing we did yesterday, that was a 1 day excursion. Does everyone have a good handle on the whole no solution infinite thing? Not bad, right? Not hard at all. Okay, so today we're going to head back into the land of inequalities. And I advertised this in seventh hour, and I could not figure out how this happened. And again, like Mr. Smarty there, they might have been just being sarcastic and patronizing me, but they seemed excited to learn what we're going to learn today. So what we're going to do today is we're going to do systems of inequalities, but there's going to be more than two inequalities. So we'll just kind of work this first example together. I made the first couple pretty easy, and then the third one's just a little bit of a step up, and then you'll kind of see what it looks like when we have more than two. This lesson is preparatory for the way you apply systems. The way you apply systems of inequalities is often in what we call optimization problems, where if you were like running a business, everything that has to be true, like I can only create 5 of these and 10 of these a day, or I have to sell more than 40 of these, or these cost $20 to make, stuff like that. You can turn those into equations. And then if you graph them, they actually make shapes like what we're going to see today. And then you can actually optimize, we call that. You can maximize profit, minimize expenses, stuff like that using mathematics. So this lesson today is just kind of a setup for all of that. That's way down the road. So anyhow, this is the 18th. And we're going to do inequalities. So we'll just call this inequality systems. And then we'll put a little comment here that says more than two. Because all of the inequality systems that I've had you do so far, there have been two inequalities. And so we've had some shading, and then we just shade in the area where the shadings cross over. Do you guys remember the one type of problem when we don't shade at all? Mm, yeah, so if we were doing like if we had two parallel lines and the shadings, one of them went below and then the upper one went above, good, that's when we don't shade at all. But that's pretty uncommon. So anyways, today we're going to do problems that have more than two. And they wind up potentially being enclosed regions, as you'll see. So our first inequality is going to be y is less than or equal to x plus 5. Y is less than or equal to negative 2x plus 8. And y is greater than or equal to 2. So you guys have been hanging around with me long enough to know this, but why is this nice? Solved. That's becoming a really important thing in our world, is if someone took the time to get y by itself, that's the huge load off of our backs that we don't have to deal with. So ready? Let's graph. And you've all got your rulers and your pencils, and let's do this. So I'll color code this. Let's do red first. Where do we start the red graph? Good job. So let's all go up 1, 2, 3, 4, 5, and stick a point there. And what is the slope of this first line? Up 1. Good, good. By the way, you will not see any dotted lines today. That is no longer something that I want to concern us with, not for this little period. So all of the lines that you do are just going to be solid. You don't have to worry about that for a little while. And good job, Josh. So we're going to go up one, right one, and our line is going to wind up being like this. Oops. Should try that again. There we go. Now, remember that with systems of inequalities, we don't actually want to shade yet, right? We just want to draw little indication arrows. Where would the shading go if we were going to make it? I think you should rethink that there, Captain Keogh. Hello. It does say, thank you, Keith. It does say is less than or equal to. So let's draw some little indication arrows to say that anything below this line is okay for now. That's what the less than implies. Okay. How about this second one? I'll put a yellow dot by it. Let's start the yellow graph. Where do we go first? Up 8. Well spoken. So we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. And we're going to put a dot. And what is his slope? Talk me through it. Down 2, right 1. Couldn't have said it better myself. Everyone agree with down 2 and right 1 to make sure the slope stays negative. So we're going to go down two, right one, down two, right one, down two, right one. And you can remember to keep doing that enough so that you basically spread the line healthily throughout the entire grid. We don't want little tiny wimpy stick things. That's no good. And then this last one, give him a purple label. What do we know about this guy?
He's equal to two.
Mhm,
Or
give me,
greater than or equal to two.
yeah, I get that, but like, I need some like, how am I going to make a line like this?
He's a horizontal line.
Keith for the win. Again, Keith is on a roll today. We know that when there's just a y in our equations, that it's horizontal. So I'm going to go up to two, and I'm going to graph a horizontal boundary across at a vertical level of two. And where would the shading go relative to this line?
Up.
Up. So I got a little bit behind on my shading. So let me go back to the yellow because I was a little hasty there. Back to the yellow line, where would the shading go for that line? Down. Good, because it says is less than. And again, the or equal to is kind of inconsequential right now. So they're all going to have or equal tos, like I said. But the shading, good job, Jeff, goes down. And so do you see a region forming where all of those have to be true? This is what I wanted to get through with you today. I thought, what a perfect day to fit this in is to look at these. What happens is now, see, we're used to these like infinitely long wedges of cheese that we shade in. Today, we're going to start looking at systems that go like this. And when you shade them, it's no longer quite as chaotic as you're used to, maybe. The shading actually happens within all of the boundaries simultaneously. And when we start applying this in mathematics, this region represents something called the feasible region. It's the set of all the points where all the rules that you make for yourself are true at the same time. And then of great interest, eventually become these three white dots. Does anyone know that word from geometry? The corners of a polygon. Does anyone know what they're called? If you call them corners, I got no issues with that, but they're called vertices. You guys ever heard the word vertex? So it's those vertices that we're going to focus on at some point in time. Today's goal is to get you to be able to graph these systems when there's more than two walls. That third wall or that fourth wall or that fifth wall just keeps chipping away and closing in like that trash compactor in Star Wars. It just keeps cinching the area shut. Any questions on that first one? That's it. Like that's game over. That's all we're going to accomplish. Let's do example two. And this is another one where I've kind of given you a little bit of a softball. So let's get to it. Y is no more than x plus 2. Y is at least negative 2/3 of x minus 2. X is at least 0, and x is no more than 6. Again, we appreciate this because it's already solved. We don't have to do any math, right? Just graphing. So I don't know if I have enough colors, but I'll get started with the red one on top. Again, no prep work, no math. Where do we start the red graph at?
Up to.
Good job. And what is his slope?
Up one, that one.
Perfect. So I'm going to grab my line tool and you're going to make up some points. Remember, it's not about the number of points that you make. It's about the fact that they just have to be far apart from each other. So make sure you have a nice spread out line with a slope of 1 and a y-intercept of 2. Where would the shading go relative to this line?
Down.
Good job. So, and if I forget to do one of them like last time, you got to yell at me, call me out. All right, second line, I'll switch to yellow. Boop. How do we start the yellow dude? Well spoken back there. Let's go down 2 and put a dot. And what is the slope going to be?
Down to right 3.
Perfect. You're like butter. You're on a roll. So a slope of 2/3 is represented by a ratio of 2 to 3. Make sure your line goes downhill because not having it go downhill would be embarrassing, right? And where will the shading go off of this? Good job. So this is what we're used to is like this is where we in the past would have stopped and said, "Yay, look, we got the infinitely long chunk of cheese there." But now we're going to start closing in some walls, and that's where these third and fourth and fifth ones come into play. So purple it is. Bam. Tell me about that line. What is it when there's only an X?
It's just at the origin.
Who said vertical? Thank you, Peyton. Very good. It is a vertical line. So I'm going to go to wherever X is equal to 0, and I'm going to graph a vertical line like this. The purple line is vertical. Where will the shading go relative to that? Hold your horses now there, Nashville. This says is greater than.
It goes up.
Numbers get greater when we go to the right on a number line. Remember that verticals are the only lines in the world that don't have upsides and downsides. We have to switch our thinking and say right or left. And in this case, going to the right makes a lot more sense because greater than means that. See the region starting to take shape, I hope. I can kind of show you a little bit where the region is starting to form. Do you see this corner here
Yeah.
and this white corner here? That's the feasible region that's starting to take shape. But now we need a fourth constraint, a fourth boundary. I'll switch to green. Tell me about the green line.
X is greater than 6 means the vertical
So,
line.
good job. So we're going to go, good job. So we're going to go right 6, 1, 2, 3, 4, 5, 6, and we're going to graph a vertical boundary like this. And where will the shading come off of that boundary? Good job. Back to the left this time, because less than means things get smaller. And horizontal numbers obviously get smaller when you go to the left. So you can see now that the region is officially defined. The walls have all closed in. This is not an infinitely large region. It does contain infinitely many points, but it's not infinitely large like some of the ones that we're used to. And then your job at that point is to just shade it in. And you can be as artistic as you want with this. Some people are heavy duty. They make them look so nice. And then some people, it's just like, that's kind of the opposite, you know? So it's okay either way. Any questions so far? One more. I don't think I'm holding on to my 15 minutes, but I'm trying to get there. So any questions? All right, what am I going to change? Yeah, I'm going to make you do a little math on this one. So did you just groan? Goodness gracious. How about this one? Do you like this one?
Yeah.
Okay. Do you like this one? Okay. Do you like this one? But it's okay. It's not that bad though. What makes it kind of in the Goldilocks zone there? It's not perfect, but it's not terrible. What could make it worse? You
If
think?
X had a number 2.
Hmm. Maybe. Or if that were a
Minus.
right. And having said that, I present to you Exhibit D. So the third one, we're not going to have much stress because we don't have to worry about a negative and dividing and switching the sign and all that stuff. But this one, I'm going to make you work a little bit harder. But again, I'm so proud of the work we've done all year. I'm so elated with the quality of your guys' learning to this point. I don't just, and I've told you this before, I don't just say nice stuff. I'm impressed with your skills. So we're not scared. So let's just kind of ignore the top two and let's get down and let's do our math. Let's talk about this third one first, the x plus 2y. What would we do with that one?
You go up to on the y-axis.
This needs solved, right? Got to get that y by itself. What are we going to do? Yeah, Peyton, let's get that x to the other side. So we're going to be left with 2y is less than or equal to what?
X.
¡Punto! Tiene que cambiar positivo a negativo cuando moverlo a la izquierda o a la derecha.
Negative X.
Negative x, thanks. Did you just learn to speak Spanish or did you just know what I was
I heard
talking
you.
about?
I heard negativo, which
Okay, context, good. And then what do?
we
Divide
divide.
by 2. And as I've said probably 100 times, I really like to show this step more than the other steps, just because seeing division helps me see fractions and stuff. So my ready to graph answer is y is less than or equal to what?
One negative one half.
Nice. So what I'm going to do, since I record all this stuff and you've written all this down, is I'm going to take some things now, and I never want you to do this on paper. I just do this because I like my board to be clean for your learning. I'm going to take that new and improved version and I'm going to put it over here in its place, leaving us with one more to do. And this is the one that we ought to feel just a little bit of stress about, and it's all because of
The negative side.
that guy. So what do we do first? Yes. So our next line will say negative 3y is still less than or equal to, what will the right side say? Perfecto. This is it. This is the step that pretty much makes us or breaks us. What do we do? Divide by negative 3. You sure do. Right? Not a lot of things that you really got to memorize, like ruly kind of stuff, but that's a big one. And that one's really just going to kind of be present forever. So when we divide by a negative, we have to take our Pac-Man and switch it the other way. What's our slope going to be? 2x. What's our y-intercept going to be? Perfecto. So having done the work now, we have earned the right to say that our system is ready to graph. There it is. Let's get this done. I want to give you guys some work time. So here we go. Purple one first. What do I do to graph the purple one? What is it? What is it? What is it?
Vertical line.
Yeah, man. It's a vertical line, and I'm going to graph it right wherever x is 0. So I'm just going to go right there. Kabam, boundary done. Which way do I shade?
You shade to the right.
Perfecto. Again, do not shade yet. Just put little arrows. Otherwise, you got a big old mess on your hands. How about this red fellow? How do we graph him?
Uh, Horizontal line.
Good job, man. So I'm going to go wherever y is 0. That's also known as, well, the x-axis, and I'm going to make a boundary. And where will I shade?
Up.
Nice. By the way, you're going to start seeing these two constraints. These two, I'm bracketing them. You're going to see these a lot. Basically, what it does is it eliminates quadrants 2, 3, and 4. And you'll see those two inequalities a lot more in word problems because things in the real world often aren't negative. Number of these and number of these hours you can work, stuff like that. Those are non-negative values, which is why those two inequalities, sometimes they travel in a little pack to rule out all the other stuff. How about the third one? How about this yellow fellow? How do I start that?
You go up 5.
Absolutely.
And you go down 1, right 2.
Yeah. Again, solid. No need to worry about that. Where would we shade relative to this boundary? Down. So we can see now that the shape has taken some form, right? It's a little perfect right. I know, Peyton, I'm working on it, buddy. We're working on a perfect little right triangle here. There's one more constraint to go, and it'll be this green one here. What do we do with the green one?
You go down 10.
Yeah, I'm gonna go all the way down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kaboom, like that. And what's his slope?
And you go up 2, right 1.
Yeah, nice job. Good enough. So do you see it? So this is what we're going to work on today, is creating these little regions. You can see that to be right of the purple line while also being above the red line, and then being above the green line while also being below the yellow line, sets us into a set of points now that look like this shape. Just a pretty run-of-the-mill, boring kind of quadrilateral. So you should have just used 3 of your 4 graphs. Does that sound about right?
Yep.
Okay, I got one I want you guys to do just because I want to see if you learned. Will you do that for me? How long will it take you to do one of these by yourself? 3 minutes? 5, 4? All right, on that last piece of graph, I want you to write this down. This one, I am not going to provide you any assistance whatsoever. And I want you to do this and I want you to get this into me as soon as you can. You'll turn it in with the notes you just took and then I'll give it back to you. Cross my heart. Got it? And then after that, you can work on yesterday's assignment or you can work on today's assignment. Either one. Here it is. Negative x plus 2y is less than or equal to 2. 6x plus 3y is less than or equal to 18. And then here comes the difficult one. What am I going to do to make one of them difficult?
Put a minus sign.
Put a minus in front of the y, right? But we can't avoid these things. Like just because it's difficult doesn't mean we run the other way. We practice it until it doesn't bother us anymore. So this last one is negative x minus, watch out, 2y. That's a sign flipper, is less than or equal to 10. And then here's an easy one for you. Do you understand your task? I want you to get this done. I want you to put it on that fourth blank graph, and I want you to give it to me as soon as you're done so I can take a peek. Good.